Yeah, so usually, when I come up here, I'm talking about, what's the latest new feature in Java or project that we've just shipped, and I want to sort of take zoom out a little bit and talk about the process of building some of the features that we've built into Java over the last several decades. So the way we work is a little different from the way most people work. So most developers. The life cycle of developing a feature could be measured in days or weeks for a lot of features. For the work that we do, we generally measure this in years and sometimes decades. Projects like Lambda, like generics, like modules, like Loom, like Valhalla, these are almost all decade scale projects. And it may not seem that way because if you measure from the first time the JEP draft is filed or the JSR is filed to the time it's released, it may look like it may not look like a decade. But very often the work has started many years before we actually file a JEP or file a JSR. So for example, with Lambda, some of you were in this room in 2006 when DevOps was called Java Polis, and Josh and Neil came and offered their competing visions for how we would add closures to Java. And there wasn't any official plan at that point. There wasn't a JSR. They were they had explored the design space independently and came here with their ideas. And that's sort of where the Lambda clock started, because 4 years later, when we filed the JSR for it, a lot of the design space had been explored, and we'd already been thinking about it for those intervening years. The same thing is true with modules. There were a couple of false starts, JSRs 277 and 294, which were later withdrawn. But the things that we learned in those explorations informed the development of the module system, which then took almost a decade, to deliver as well. And Loom, if you measure sort of in the obvious way, so Loom took 5-6 years, but it really took a decade as well, because before there was Loom, before Ron Pressler came to Oracle, he had a company where they had a product called Quasar, which was basically the prototype of Loom. And so when we started with Loom, we had already learned, or at least Ron had, a tremendous amount about what worked and what didn't work. And I'll be talking, tomorrow about Project Valhalla, which has, in the last year or two, made some pretty impressive progress. So the things that we do take a long time. Okay, why does it take this long? Well, there's quite a few reasons. Obviously, the problems we're solving are often complex. There's a large design space to explore. There are a lot of roads not taken that still have to be explored and then identified as, okay, we're not going to go that way. Another obvious reason why things take a little bit longer in Java than in a typical application is compatibility. And this has a lot of different forms. So obviously, we don't want to break anybody's code. Obviously, we don't want to break anybody's understanding of what they've learned about Java in their career, because we don't want to invalidate the investment that you've made in your code and your expertise. But also, we have to be compatible with the future. We can't do things today that we don't want to be compatible with tomorrow. And that means we have to do a fair amount of crystal ball gazing about which of these 17 directions might Java go in, or maybe all of them, and make sure that what we're doing today isn't incompatible with that. And we also have to give people a compatible path from the present to the future, so that if you want to adopt lambdas or generics or modules, we don't expect anybody to have a flag day where they cut over all their code at once. That couldn't possibly happen. And so there has to be a way to gradually, at your own rate, and not necessarily all at once, migrate your code to use the new features. So these are all things that make things take a little bit longer. We also, in addition to having to solve the technical problem, we understand that Java developers have to have to be able to absorb new features at their rate, and that means there has to be a simple story that builds on what people already know, and fit and finish. The last 10% often takes a long time, and then the last one that we don't even talk about very much is sustainability. We want to leave the platform at least as clean as we found it, because no feature is the last feature. If you build something that's really, really complex, building the next thing on top of it is even harder, and we're nowhere done, making more Java. So we want to leave things at least as simple as we found them. So that's a lot. That's hard. Why do we do it? Well, we have to, right? We're caught in this constant balance between conservation and innovation. The things that I mentioned in the previous slide, those are all about conservation. Those are about not breaking things. And that's expensive, but if we don't do it, we're pretty much baked, right? Java would eventually become irrelevant if we, got the reputation that we, just went off and broke your code every 6 months. On the other hand, Java would also become irrelevant if we didn't keep innovating. And so, we have to, we have to balance these two forces, and it's a difficult balance sometimes. It's always fun and a little bit, a little bit scary to go back and look at the Java code that, maybe you personally wrote 15, 20, 25 years ago and think, wow, did we really program like that? And we thought it was good, right? So we can't stand still. We don't want to live in, in that world from 20 years ago. So one of the things I observed from doing, a number of big projects is that there's kind of a common life cycle across all of these successful big projects. They all kind of start out with a great deal of optimism, with a great idea, which turns out to not be as great as it as you thought it was when you got started. And then, they all involve sort of a similar search for what we call, what's the primitive here, right? My friend and colleague John Rose likes to say that the main game that architects play is called find the primitive. And very often you have an idea of okay, we're going to go do this, and that's going to be the thing that we're going to build this feature on. And it turns out that's not actually the bottommost thing, that you need to be building. That's really more of a consequence of something else. And sometimes it takes a while to figure that out. Now, the design process, if any of you follow, some of the OpenJDK, development lists, is often a meandering thing. And sometimes it kind of winds around in a spiral where we'll start out with some design idea, we'll wander away from that, and then we'll come back to it with a little bit more understanding of, having done some explorations and understanding the problem better. And we'll come back to the same point, and people will say, "You idiots, you were there 3 years ago. What did you do for the last 3 years?" But the process is necessarily iterative because you don't necessarily understand things from the outset, and you want things to not look nailed on the side. And as you're sort of meandering through the design space, you're invariably going to discover opportunistic side quests that you think, oh great, we'll solve this problem as we go along. And very often that accrues to your detriment, as I'll discuss a little bit more later. So having looked at the life cycle of generics and lambdas and modules and Loom and Valhalla and sort of spotting these commonalities, I thought, well, I can't be the first person to observe this. There must be some already characterized life cycle for these things. So I started looking around, how many people are familiar with the Gartner hype cycle? This was coined in 1995 and talks about how all technologies, they burst into the public consciousness, they get super overhyped, and then things crash to reality when we discover it's not as perfect as we thought, and then there's a sort of slow climb out till we figure out what the technology is for. And Gartner has made a great business applying this cycle to dozens and dozens of technologies over the last few decades. But that wasn't, even though it kind of starts out that way, that wasn't what I was looking for. So I tried something else. Someone suggests, well, what about the 5 stages of grief? And I have to say that these projects often do involve a certain amount of denial and anger and bargaining and depression, not necessarily acceptance. And does anybody notice all of these models have 5 stages? It's some hidden marketing rule that if you have a life cycle diagram, it has to have 5 steps. But no, this wasn't the right one either, and so I decided I had to make up my own. So I call it the peak of complexity model. It starts out like the Gartner hype cycle with a lot of optimism. I've got a great idea. This is going to be easy, right? And a colleague of mine observed that the developer's credo is, we do these things not because they're easy, but because we thought they were going to be easy. And yeah, this shows up in every project. And then of course, you slam into reality, again, just as with the Gartner cycle, and you start cursing the idiot who kicked this project off. And so when I say, I call this the trough of despair, and you can think of it as like imagining Mel Smith in The Princess Bride saying, "The pit of despair," because that can feel that way sometimes. But like, if you make it through the pit of despair, you begin this long, slow climb where you like chip away at various aspects of the problem. And each time you chip away at a little aspect of the problem, a little bit more complexity gets added to your solution until you reach what I call the peak of complexity. And this is where you have a solution. I'm going to put this in quotes. You have a solution and it works. But this is the most dangerous moment of the project, because you're going to be tempted to ship this solution because you've been working on it for a while and you have a solution. That is the worst possible thing you can do. So when I say the peak of complexity, you could imagine Wallace Shawn in The Princess Bride saying, "The cliffs of insanity," because it really would be insane to ship this thing. But if you manage to avoid the temptation to ship this thing, you have a chance of entering the phase that I call the virtuous collapse, where you realize that you've actually solved too many problems at once. And you can actually remove some of your requirements and thereby make the solution simpler. And as you take one piece out, it enables a simplification somewhere else. And then at some point, if you're really lucky, and after a lot of iterations, the complexity just sort of collapses. And you say, where did it all go? And then what everybody else says is, what took you so damn long, right? But because you come out and you say, look at our simple solution. And they say, that took you 10 years? I could have told you that. So it's a little bit like the old quote from Blaise Pascal of, "I apologize for writing you a long letter. I did not have time to write a short one." It is a long and painstaking and iterative process to take a complex solution and boil it down to something simple. So when you get to the peak of complexity, this, as I say, this is the most dangerous moment of the project. You will be tempted to ship this solution. After all, you've been working on it and you finally solved it, right? And if you make the mistake of shipping this solution, you will never get to the virtuous collapse, because you will spend the next however many decades just maintaining the complexity of the monster that you've built, and probably adding more complexity onto it, because any initially complex solution is going to be incomplete. It's going to have errors, it's going to have gaps, and the only tool you're going to have at that point for patching it is adding more complexity to it. And so, it is, you'll be tempted to ship it, you'll be tempted to say, and we can simplify it later, but you can't. Once you let the monster out of the box, you're never putting it back in the box. And so, when you reach the peak of complexity, this is an opportunity actually for your product to jump the shark, right? It's easy, to ship something that's not ready to ship, and you're going to be paying for that forever. So shipping your peak of complexity solution is dealing with complexity by saying, I've reached the peak of complexity and now I live here. And when you live at the peak of complexity, well, the view's great, but the weather kind of sucks. So it's, we've been very lucky. We've managed to avoid disaster most of the time. And so, people look at us and say, you guys are just too cautious. You're just a bunch of perfectionists. You could ship it a little bit earlier. But we do have an example in our history of what failure looks like, and as some of you probably had already guessed, it's serialization. Serialization is the poster child for having shipped your peak of complexity solution. Now, this was something that was largely rushed into Java 1.1 for what actually might have been good reasons. But we have been literally paying for this mistake for decades. And this is because serialization is a veritable fountain of complexity. every aspect of it is complex. The mechanism is complex. You know, it does magic and extra-linguistic state extraction and magic extra-linguistic object reconstruction that's outside of the programming model. And you have complex mechanisms for customizing it, and it interacts with just about everything. And we've spent the last 30 years playing catch-up and patching security holes because we shipped this peak of complexity solution. Now, actually, we'll have a talk later this afternoon, Victor and I, about what are we going to do to finally fix serialization. But it's been a long time coming. Also, another fun talk later today, Stuart Marks is going to talk about the fun and hilarity that ensues when you try to serialize cyclic object graphs. So you may want to check that out just for some good war stories. So let's say you're lucky enough to reach the peak of complexity. You've been working on a problem for a long time. You have a solution that works. How do you know that you're there? Because when you reach the peak of complexity, you actually have a new job that you're supposed to take on, which is navigating to the, navigating your way to the virtuous collapse. But you may not realize that when you get there, right? When you reach the peak, you're in this mindset of, I did it, I got there. And you've spent the last several years focusing on, is there a solution at all? Can I prove that there is a solution? Not how good is my solution? Is it the best solution? Is it the minimal one? And so, you arrive at this place and you think, okay, this is the time, this is the time to declare victory, when in reality you're only halfway there. And of course, this happens in a context. Management wants you to ship something. You want to ship something. Your customers want you to ship something. And it takes it takes a lot of discipline to say, wait, no, we're not actually done. And now the job is navigating our way to the virtuous collapse, which is a new and different job. So some of the risks that you can encounter when doing this is you can fall in love with your complexity. It's very easy when someone says, oh, that solution is very complex, and you say, yeah, it is. It's a really complex problem. Of course the solution is complex. That's denial from the 5 stages of grief talking. When people point at individual aspects of the complexity of your solution, you kind of remember how each bit of complexity was added to the solution, and each bit, was there to solve a particular problem, and it will feel like hard-won progress. And when people say you should simplify it, it almost feels like they're trying to take your victory away from you. So that's falling in love with your complexity. Don't do it. We experienced this when we were doing Project Loom. So before Project Loom framed itself as delivering virtual threads, it was all about fibers. And the fiber abstraction was completely separate from the thread abstraction. And that seemed like it made sense. It's a new thing. It should have a new name, right? But it made it very difficult to interoperate with frameworks that knew about threads because they didn't know yet about fibers. And it would have been imposing a big burden on all of these frameworks like executive service and such, to learn separately about fibers. And we resisted, fusing fibers into threads at first because it felt like, no, they're a different thing. It should have a different name. But we eventually realized that was just falling in love with our complexity. So the other thing that can really slow you down in getting down from the peak of complexity is not realizing that you picked up a lot of things along the way. You've spent the last however many years solving a problem, and along the way you found a bunch of other problems that you wanted to solve as well. And we like solving problems, we consider ourselves problem solvers, so it's very easy to pick up opportunistic side quests or say, oh yeah, I always hated that, I always wanted to fix that, I'll fix that as I go along. And the problem is that these opportunistic side quests, they sort of maybe align with the real problem you're solving 95%, but very often not 100%. And that misalignment is where a lot of the complexity comes from. And so, one of the hardest things to do is to recognize that you've engaged in some mission creep and that you need to reduce some requirements, throw them out, so that you can start the process of simplification that moves you towards that virtuous collapse. And so it's a very different mindset to be looking at every sub-requirement and saying, do we need this? Can we get rid of this? If we get rid of this, what else can we get rid of? And when you're in the middle of it, every one of those aspects of the feature feels essential. I remember when we did Lambda, and we were getting to the end, and we knew we had to cut some scope. And so there were a bunch of things that we were working on that we said, OK, we're not going to deliver these things. We'll deliver them in a future version. And we very dutifully kept a log of what had we worked on and thought we were going to put in, and we're deferring to the next version. And it was really hard. Each one of them felt really essential. And then a year later, we sort of opened this notebook up again and said, OK, let's take a look at what's on the to-do list for the next version. And we realized that not a single one of them was actually important. But when you're in the thick of it, it's everything seems important because these are exciting, interesting problems to work on, and we're problem solvers, right? So, and it's even harder to cut a requirement when you already have a solution for it, right? It's we've already done the work, but you haven't actually done the work. The work isn't the real cost. The real cost is the complexity. So, and the collapse doesn't happen just all at once. It happens slowly over time. It happens over many iterations. Each simplification ideally can beget another, and at each step of the way, you're fighting okay, so we're done now, right? Which is a natural temptation that we all have as developers. So it requires a very different mindset, and you kind of have to strap in for the long haul. So just a few closing thoughts. We're drowning in complexity. And complexity is very much like entropy. The world naturally tends towards increasing complexity. And that if you want to decrease complexity, like decreasing entropy, you have to inject energy into the system. Now, we think of ourselves as problem solvers, but complexity is often the side effect of solving problems. And, if we don't have problems to solve, we'll find some because we're problem solvers, goddammit, right? And so we should not judge the success of our work on, look at the cool features we deliver. We should judge the success of our work on that and how much complexity did we have to add in order to get there, or ideally, could we have gotten there by removing complexity? Because you're not done when you've solved the problem. You're done only when you've cleaned up the mess you made while you were solving the problem. So there are a bunch of talks from folks at the Java Platform Group here at DevOps this week. I want to highlight one of them that I'll be giving tomorrow on Project Valhalla, which is sort of illustrating the virtuous collapse that we... Oh, you look great, man. Valhalla has recently gone through its virtuous collapse. It's been a pretty amazing thing to watch, and so I'll narrate some of the the key plot points on that. But there are a number of great talks from folks on the Java team this week, so I hope you check them out. And thank you very much.